Hi, Christine. Thanks for sending your question. I'm really loving your picture here, and I see that you wrote tan up here, so we're going to be utilizing some trig functions to solve the first part. So for the first part, let me show you my own picture. It looks like this is where the boat starts. This is where it makes a right-hand turn and then goes north. And then this is where it has to turn around and head back to port. And we're looking for this angle, little t. And to do that, you're absolutely right. We're going to use a tangent function. So by Sohcahtoa, I don't know if you've ever heard of this, but what it stands for is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's apply Sohcahtoa to this triangle. So since we're looking at this angle here, the tangent of that angle, t, is going to be the length of the opposite side, which is 150 miles, over the length of the adjacent side. So opposite over adjacent. But we're not actually looking for what the tangent is, we're looking for what t is. Let's go ahead and simplify this here. So we're going to use a tangent inverse function. And given that this is a tangent that you probably don't know off the top of your head, I don't, so we're going to use a calculator. So we're going to type tangent inverse into our calculator, and we're looking for the tangent inverse of 15 over 4, and that's going to give us angle t. That's going to be an approximate angle, and that angle will be approximately 75.1 degrees. So that's part one. For part two, we're going to go ahead, we're looking for time. So anytime we have straight linear distances like this, or distances in a line, there's a very simple formula we use, d equals rt. The d stands for distance, the r stands for rate, and the t stands for time. Let's go ahead and figure out what information they're giving us and what information we're looking for, and see what information we have to fill in. So looking at your problem, it looks like they give us the rate that the boat is traveling at. The rate is 23 miles per hour. So let's go ahead and make a table and mark that down. So r equals 23 miles per hour. And we're looking for, let's see, how long, so we're looking for the time. We're not going to be able to fill that in because that's what we're looking for. So what we're not given is the distance. So to be able to solve for time, we're going to have to figure out what d is. To figure out what d is, I'm going to turn to the trusty Pythagorean Theorem because it's something that you're probably already familiar with. The Pythagorean Theorem goes a little something like this. Let's call this side, side d, the distance it's traveling back to port once it's turning back around. And let's call this side here side A, and this side here side B. Then side D has this relationship with side A and side B. A squared, the length of side A squared, plus the length of side B squared is equal to the length of side D squared. We know the length of side A. Let's go ahead and put that in there. That's 150 squared. We know the length of side D, or I'm sorry, side B, that would be 40 miles, so we'll put 40 squared in there. That's going to help us figure out side D. Let's go ahead and simplify this side. If you plug 150 squared plus 40 squared into your calculator, you should get 24,100, and that's equal to d squared. So we're going to take the square root of both sides, and we're looking at distance here, so this is only the positive square root. And that value there is going to be 10 times the square root of 241, or approximately 155.2, and its distance, so our unit, is going to be miles. So let's go ahead and plug that into our table. And once our table's filled out, we can go ahead and solve for t by just plugging in R and D. Well, I'm going to go ahead and do that over here. Let's rewrite the formula. D equals RT. D is 155.2 miles. You're going to notice that I'm writing down all my units here because I want to make sure I have the correct units at the end. That's going to help me double check my answer. The rate is 23 miles per hour. We're going to write that like a fraction. And T we don't know, so we'll just go ahead and keep it there. This little dot is for multiply. What I'm going to do is I'm going to divide both sides by 23 miles per hour. Dividing is the same as multiplying by a reciprocal. So the reciprocal of my number 23 is 1 over 23. And the reciprocal of miles per hour, we're just going to flip, and it's hours per mile. And that's going to be T. So we know T has to be a unit of time, so we should end up with units of hours when we simplify. Let's go ahead and simplify our units first. Miles will cancel miles here because we're multiplying. And it looks like the only unit we're left with is hours, so we know we're going to get probably the right answer. So dividing 155.2 by 23, you're going to get approximately 6.7 hours. And that's the final answer to your question. Thanks again for your question, Christine, and I look forward to answering more of your questions using SnapMath in the future.